one very nice matrix, and this is wonderful matrix 1 0 0 0 0 1 0 1 0. So this is a wonderful matrix, and we have calculated the eigenvalue. The eigenvalue is equal to lambda is equal to -1. You can say it is lambda 1. Lambda 2 is equal to 1, and lambda 3 is equal to also 1. And you can say this is my non-degenerate eigenvalue, and these two are what? Degenerate. And these two are degenerate eigenvalue. Degenerate. Okay. And we have already calculated this particular, the eigenvector corresponds to lambda is equal to -1. So what is the eigenvector corresponds to lambda is equal to -1? So lambda is equal to -1. We have calculated phi 1. And what is that particular value? That particular value is 0, 1 by root 2 minus 1 by root 2, isn't it? And this is normalized one. So we have calculated this particular thing. Now, the real challenge is that we have to calculate the eigenvector corresponds to lambda 2 is equal to 1 and lambda 3 is equal to 1. So when you will write the eigenvalue equation, you will get exactly same equation from both the lambda, because both is same. Both are same, isn't it?
Yes, sir.
Anna? So but we have to find the eigenvectors who is basically orthogonal to each other. This is our real challenge. If we are not able to find that eigenvectors are orthogonal to each other, then what will happen? It is very difficult to make a complete basis. Are you getting my point? So let us see how we can get all this thing. So yes, so first I will go for phi 2. Don't worry. So phi 2 is equal to, let's say, B1, B2, B3, and we can put A phi 2 is equal to lambda 2 phi 2. And we have A is 1, 0, 0, 0, 0, 1, 0, 1, 0, and you have B1, B2, B3, and that value is equal to 1, B1, B2, B3, and from here B1 is equal to B1, isn't it? And you have B3 is equal to B2 and B2 is equal to B3. Everyone is comfortable?
Yes, sir.
So you have a vector, and that vector is phi 2, which will be B1 is equal to B1. How many values you can have?
One.
Only one?
Infinite.
Infinite number of values. You can have infinite, any value. 1 is equal to 1, 2 is equal to 2, 3 is equal to 3,
Yes, sir.
0 is equal to 0. Yes?
Yes, sir.
So you have B1 is any arbitrary value. And another vector is all about B2. Another component is B2, and B3 is equal to B2. Now this should be the nature of phi 2. And what should be the nature of phi 3 also?
Same.
Exactly same, because you have to solve the same equation. I am just writing it in term of C. So don't worry. The phi 3 will be C1, C2, C3. Yes? We have to solve exactly same equation. Now the question is that. The question is very, very interesting. Look at B1, B2, B2, and C1, C2, and C1, C2, and C2 is there. So now you can see there are fair chance that these two vectors are more or less parallel, isn't it? And at least they are not parallel. Can I say they are just belongs to same plane? Isn't it?
Yes, sir.
Now look at what is going to happen. How many type of vector, how many vector you can choose B2? Leave the normalization part. Leave normalization. Normalization is not a big issue. You can easily normalize it. So what is my question? My question is very interesting. How many vector you can make which is property of B1, B2, B2? How many vectors?
So many.
So many. Infinite number of vectors.
Infinite.
Okay. Now, and how many vectors you can make phi 3, which will be C1, C2, C2, or same like B1, B2, B2, isn't it? Both can be same type of matrix, isn't it? Means this element is equal to this element and this element is something different. But what we have to do now, look at, we have to, and now look at, do one exercise before going to the next one. Just take the scalar product between phi 1 and phi 2 and phi 1 and phi 3. What you will get?
0.
0. B1 into 0 is 0. B2 into 1 by root 2 minus B2 into 1 by root 2 is equal to 0. So this vector and this vector is naturally orthogonal to each other. Isn't it?
Yes.
Now look at what is going to happen. हाँ sorry हाँ बोलो.
Repeat it again.
मैं फिर से बता रहा हूं. देखो, this vector is orthogonal to this one. You can just do the scalar product. What will happen? Phi 1 and phi 2. Just copy में करके देखो. क्या नाम है आपका? Just copy में करो. हाँ
Okay, sir.
हाँ
0.
0 आ रहा है ये. Just do it.
Yes, sir.
So this will be naturally 0. And you have phi 1 and phi 3 also is equal to 0. Means any vector whose has property of B1, B2, B2 type vector is 100% orthogonal to this one. Are you getting my point? Any vector 1, 0, 0, 0, 1, 1, 1, 5, 5, 10, 3, 3, all vector are orthogonal to this one. Okay?
Yes, sir.
है ना? All vectors. Now the question is that the orthogonality between this and this is very trivial. But orthogonality between phi 2 and phi 3, is that trivial or non-trivial?
Non-trivial.
They are non-trivial. Why? Now look at this thing. Now you can assume this is my one plane and phi 3 is and phi 1 is perpendicular to that plane. Can you assume something like this? Are you getting my point?
Can you repeat, please?
What I am trying to say, phi 1 is perpendicular to this plane of the board. So any vector which will in the plane of the board is orthogonal to this vector.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
सोच लो, अच्छे से सोच लो, बहुत ही इंपॉर्टेंट है. What I am trying to say, any vector which is perpendicular, so this phi 1 is perpendicular to this plane.
Sir.
So any vector which lies in this particular plane, any orbit vector, how many vector lies in this particular plane?
Infinite.
Infinite.
Infinite number of vectors. So all vectors are perpendicular to this particular vector. Isn't it?
Yes, sir.
Suppose
Now-
it's a-
Now, can you give the guarantee all these vectors in the plane is mutually perpendicular to each other?
No, sir.
No. No, sir.
No. Now, look at this question. Now look at. So suppose this is my.
सर कुछ स्केल टाइप का है.
वही तो मैं देख रहा हूँ. Don't worry. So look at what is going to happen. So this vector is your phi 1. Are you getting this thing? दिखाई दे रहा है ये?
Yes, sir.
हाँ, दिखाई दे रहा है. अब मैं अगर phi 2 को ये वेक्टर ले लूं तो phi 3 क्या मैं ये वेक्टर ले सकता हूं?
Yes, sir.
So suppose this is my phi 2. Then what is my phi 3? This should be something like this, isn't it? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
है ना? Suppose I am choosing phi 2 something like this. What is your phi 3? Something like this. Now, if someone is choosing phi 2 this one and phi 3 this one, is that this is going to work?
No, sir.
No, sir.
No, sir.
No. If you are choosing phi 2 this one, your phi 3 must be this one, isn't it?
Yes, sir.
Yes, sir.
If you are choosing phi 2 this one, then phi 3 must be like this, isn't it?
Yes, sir.
Yes, sir. Sir.
And all vectors are orthogonal to this vector. Look at, isn't it? हाँ है ना?
Yes.
Yes, sir.
Now, चलो मेरे साथ साथ आप बताओ. Is that this phi 2 is orthogonal to this one?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Is that this phi 2 is orthogonal to this one?
Yes. Yes, sir.
Yes, sir.
Is that this phi 3 is orthogonal to this one?
Yes,
Yes,
sir.
Yes, sir.
Is that this phi 3 is orthogonal to this one?
Yes,
sir.
Yes, sir.
Okay. चलो अब फिर से आप बताओ yes या no में. Is that this phi 2 is orthogonal to this phi 3?
Yes.
Yes, sir.
Yes, sir.
Is that this phi 2 is orthogonal to this phi 3?
No.
No.
No. Is that this phi 2 is orthogonal to this phi 3?
No.
No. Is that this phi 2 is orthogonal to this phi 3?
Yes. Yes, sir.
Yes. What you learn? All these vectors are the eigenvector of this A because they have this property. So why they are analogically in common plane. Are you getting my point? But you cannot give guarantee that all vectors or any two vectors are orthogonal to each other. So what you can do, you can assume one vector arbitrarily. Suppose I am assuming this vector arbitrarily, then the next phi 3 must be, can you choose arbitrarily or it will be fixed?
Fixed.
It will be
It will
fixed.
be fixed, sir.
Suppose रमेश ने इसे चूज किया तो रमेश के लिए phi 3 यही होगा. Are you getting my point?
Yes, sir. Yes, sir.
और सपोज सुरेश ने चूज किया तो सुरेश के लिए phi 3 यही होगा. Are you getting my point?
Yes, sir.
Yes, sir.
This is the thing all about degeneracy. So all these phi 2 and phi 3 and how many vectors you can get in this particular plane?
Infinite.
And infinite number.
Infinite number of vectors, and all these vectors are the eigenvector of A operator because they can have nature of this B1, B2, B2. But you have to choose a one particular set of a vector which will be orthogonal in nature. And there is nothing to do with the phi 1 and phi 2 and phi 1 and phi 3. They are arbitrarily, they are trivially orthogonal to each other, isn't it?
Yes.
Yes, sir.
समझ रहे हो मैं जो बात कहने की कोशिश कर रहा हूं. So what you will do, you can choose any phi 2 arbitrarily. So I am just choosing my phi 2 is equal to, let's say, 1 0 0. Can I choose?
Yes, sir.
Yes. Then what will be my phi 3? Then my phi 3 must be orthogonal to this one, isn't it?
Yes.
Then what will happen? Then you have phi 3, phi 2 must be equal to 0. So what you will get? So from here you have to solve one equation, and sorry, this equation is equal to C1, C2, C2. You can take C2 star also. And here is phi 2 is equal to what?
100.
100. That must be equal to 0. So from here, C1 star must be equal to 0. So C1 must be equal to 0. Isn't it? And now what will value of C2? Then be any arbitrary value. So your phi 3 must be 0, C2, C2. If you are choosing your phi 2 is 1 0 0, then your phi 3 must be 0, C2, C2, and you can find the value of C2 with the normalization constant, isn't it? With the normalization condition. So what will be value of phi 3? The value of phi 3 phi 3 is equal to 1. And from here, you will get C2 is equal to 1 by root 2. So from here, what you learn? How many orthogonal set you can make from here?
Infinite.
Infinite number of orthogonal set you can make. So we have make one particular set. Let's try to go for another set. This is also interesting. Are you getting my point? समझ में आ रहा है ना? Just a bit.
Yes, sir.
है ना? And this is beauty of matrix values of matrices. Okay, let's try to go for a final conclusion right now. So ये सबको मिटाऊं. So what you have, is that any problem? चलो, everything is okay ना? Because को sound नहीं सुनाई दे रहा है. Okay, so what is my phi 1? Sorry, what is my lambda 1? Minus 1. What is my phi 1? 0, 1 by root 2 minus 1 by root 2. What I have chosen my phi 2? 1, 0, 0. This is normalized. So don't worry about the normalization. What is my phi 3 then? क्या था मेरा phi 3? 0, 1 by 2, 1 by root 2. This is my phi 3. Isn't it? So this is your one particular orthogonal or orthonormal set. Now, and this is for the lambda is equal to 1, and this is also for the lambda is equal to 1. Now someone can choose another phi 2 and another phi 3 also. Let's try to go for this. And again, if I am talking about lambda is equal to minus 1, I will get exactly same vector or different vector.
Same.
Same vector.
Same vector, because they are non-degenerate, isn't it?
Yes.
Non-degenerate के लिए तो आपको same ही vector मिलेगा ना? Always. So you will get phi 1 is equal to exactly same thing, 0, 1 by root 2 and minus 1 by root 2. Now I just want to find next phi 2 other than this. So what should be the nature of phi 2? Phi 2 का nature कैसा होना चाहिए? B1, B2, B2. So can I choose B1 is equal to half? Choose कर सकते हैं ना? I can choose. So I have to find what is value of B2. So the value of B2 can be easily find with the normalization condition. So I will get phi 2 must be equal to 1. And from here, you have 1 by 4 plus 2 times B2 square is equal to 1. So what is value of B2? क्या आ रहा है बताइए? Root
By
under
8.
3 upon 8.
8.
Isn't it? You can take plus or minus. There is not any problem. I am taking the plus value. So I can choose my phi 2 as that value is 1 by 2, 3 by 8, 3 by 8. Now, if this is my phi 2, can I write my phi 3 arbitrarily?
No, sir.
No. We have to use the orthogonal condition. And what will be my phi 3? My phi 3 is something C1, C2, C3. And we have to use the orthogonal condition. So we will go for phi 2, phi 3 must be equal to 0. And what you will get? C1 by 2 plus 2 times, sorry, C2, C2. 2 times root 3 by 8, C2 must be equal to 0. And from here, you will get the value between the relationship between C1 and C2. Isn't it? हाँ या ना?
Yes.
B2 square.
Huh? Sorry?
Sir,
C2
it has to
square.
be C2 square.
No, there is not C2 square. Why C2 square?
We are adding, no?
You are adding 2 times root under 3 by 8 C2, isn't it?
Yes, sir.
Huh. So what will be relationship between C1 and C2?
C1 is equal to minus 4 root 3 by 8 C2.
C1 is equal to minus 4 root 3 by 8 C2. And now you can put all this value. So you have this value is minus 4 root 3 by 8 C2, C2 and C2. And how you will get the value of C2?
By normalization.
Normalization condition. So this is my phi 3. Normalization is not issue. Issue is actually orthogonality. And phi 3 must be equal to 1. And from here, what you will get? 16 into 3 by 8 plus 1 plus 1 C2 square must be equal to 1. What you will get? You will get the value of C2, isn't it? And what is value of C2?
1 by root 8.
1 by root 8. Okay. C2 is equal to 1 by root 8. So when you will write this particular thing, then your phi 3 is equal to, you can put value of C2, that is 1 by root 8. So you will get root 3 by 2, isn't it?
Yes, sir.
Minus sign, minus root 3 by 2, and you will get 1 by root 8. You will get 1 by root 8. And this must be your phi 3. You can make another set also, isn't it?
Yes, sir.
So how many set you can make for the degenerate eigenvalue? Infinite number of set. And now look at here. Just tell me whether my statement is correct or false. Now, this phi 2 is eigenstate of A. Statement correct or false?
Yes, sir.
Yes or no?
Yes, sir.
Yes. Now, this phi 1, this phi 2, and this phi 3 are eigenstate of A. Correct or
No.
false?
No.
No,
No.
Yes, they are all are eigenstate of
Eigenstate.
A.
Yes, sir.
This is for the eigenvalue minus 1, this is for the 1, and this is for the 1. Isn't it?
Yes.
Yes,
Yes, sir.
Yes, they are eigenstate. Now, next statement is very important. Is this phi 1, this phi 2, and this phi 3 will make complete basis?
No, sir.
No, sir.
No. Very good. Very good. So either you have this phi 1, this phi 2, this phi 3, this will make complete basis, or you have this phi 1, this phi 2, and this phi 3 will make complete basis. Are you people happy?
Yes, sir.
Yes, sir.
है ना? But please remember, these all are the eigenstate for lambda is equal to 1. Look at. This is also eigenstate of lambda is equal to 1. This is also eigenstate of lambda is equal to 1. This is also eigenstate of lambda is equal to 1. This is also eigenstate of lambda is equal to 1. But if you are choosing this one as your phi 2, then your phi 3 is have to be this one. So only finding the eigenstate is not a big deal. What is the most important thing? That are you getting a complete set or not? Hold your breath, take a rest, and think whatever I have told you, which is correct or not.
सर
कोई
ये
doubt है?
कंप्लीटनेस थ्योरम भी फॉलो करेगा ना?
बिल्कुल 100%. ये सेट फॉलो करेगा या फिर ये सेट फॉलो करेगा, आप होमवर्क में चेक करना. यस
करना है.
करना है. क्या करना है? ये आप चेक कर लेना कि ये तीनों कर रहा है. वेरी गुड, वेरी गुड. आपने चेक किया? वेरी गुड.
सर वो -1 1/√2 1/√2 हाफ.
ये तो हो जाएगा आसान. इसको चेक किया?
1/√2
अरे इसको चेक किया? इसको चेक करना.
1 मिनट सर बस.
कर लेना, बाद में कर लेना. ठीक है
सर.
हाँ बताओ.
सर जैसे हमारा phi 2 आ गया, आर्बिट्रेरली हमने ले लिया. अगर हम उस पे रोटेशन मैट्रिक्स लगा दें 90 डिग्री के साथ, तब भी तो हमें phi 3 मिल सकता है.
ऑर्थोगोनल कर रहे हो तो इसका मतलब वही कर रहे हो ना,
हाँ,
ठीक है। तो अब अलग से एक रोटेशनल मैट्रिक्स बनाओगे फिर उस पर लगाओगे, उससे बेटर ऑर्थोगोनल करके नहीं निकाल लोगे?
मतलब सर बस डाउट था कि मतलब वैसे भी कर सकते हैं ना, करेंगे तो नहीं करेंगे तो वैसे ये आसान तरीका है, पर फिर
अब वो रोटेशनल मैट्रिक्स तुम कैसे डिफाइन कर रहे हो, किसके अबाउट रोटेट कर रहे हो, दैट ऑल थिंग आर वेरी इंपॉर्टेंट ना। यहाँ तो मैं तुम्हें सेमेटिकली दिखा रहा हूँ प्लेन में, बट दिस इज नॉट इन अ प्लेन, इजंट इट?
यस सर।
दिस इज इन एब्स्ट्रैक्ट प्लेन। आर यू गेटिंग माई पॉइंट?
हाँ सर।
तो ये बहुत ही टफ हो जाएगा तुम्हारे लिए, नहीं?
हम्म।
तो आइगन वैल्यू तो कभी कभी 4 आ जाएगा, तब तो दिक्कत हो जाएगी।
हाँ, सॉरी क्या बोल रहे हो?
तो आइगन वैल्यूज 4 आ जाएगा तो रोटेशनल मैट्रिक्स से
हाँ,
दिक्कत हो
4 आ
जाएगी।
जाएगा तो कैसे करोगे? वेरी इंपॉर्टेंट। यहाँ तो n नंबर ऑफ मैट्रिसेस हो सकते हैं, नहीं?
इम्पॉसिबल।
That is impossible. So why you have to go with the mathematics? Obviously, rotational matrix is also mathematics, but they can confine up to 3-dimensional vector, है ना? So obviously, you have to just take the projection of one vector with another. If you are getting 0, you are getting the orthogonal vector. What is better way to do this thing, isn't it?
यस सर।
है ना? So look at this particular thing. Look at this message. How important is your orthogonal vector? And how dangerous is degeneracy if it will come into picture? Isn't it? If you are getting the degenerate eigenvalue in a quantum mechanics, be very conscious. Why? Because there are n number of sets that you can create. Maybe one person can solve all the problem on this particular set, another person can solve all the problem on this particular set, and you will get that he is also correct and he is also correct. Why? Because they are making complete basis. They are fulfilling the condition of completeness relation. This is beauty of orthogonal vectors. Okay, so can we make a final statement?
Excuse me, sir.
Yes.
So why are we taking different sets of phi2? Can we just find a relation between B1 and B2 and find phi2?
Sorry, क्या बोल रहे हो ध्रुवी? समझ में नहीं आ रहा है.
So why are we taking different sets of phi2?
Oh, why you are taking different set of phi 3, phi 1, phi 2? Because who will give you guarantee that this is the only answer? Some person can start it from here only, isn't it? एक्चुअली आपको ये गलत मैसेज दिया गया है कि मैट्रिसेस को हमेशा 0-1 में ही कैलकुलेट करना है, इसलिए आप ऐसा क्वेश्चन कर रहे हो. आर यू गेटिंग माई पॉइंट?
Yes, sir.
आप एक बहुत बड़ी गलती करते हो कि ऑलवेज यू आर सॉल्विंग, ट्राई टू सॉल्व द मैट्रिसेस विद आइदर पुटिंग 0 और पुटिंग 1.
Yes, sir.
समझ रहे हो? आज से नहीं, पिछले 3 साल से आप ये काम कर रहे होगे. ब्रेक दिस मिथ. This vector set and this vector set are equivalent and they will fulfill the same thing. तो आप किसी को रोक थोड़ी सकते हो कि वो इस तरह से नहीं अपने प्रॉब्लम को सॉल्व करे.
Yes, sir.
ठीक है? ओके. यस
सर
हम्म
सर फिर हम फाइनल आंसर कैसे बताएंगे सर इसका?
फाइनल आंसर आप बताओगे, डिपेंड्स ऑन कि आपसे क्या पूछा गया, और फाइनल आंसर सबका सेम आएगा. डोंट वरी व्हेन वी विल गो इनटू द फिजिक्स. ओके, दीज आर एब्स्ट्रैक्ट डायरेक्शंस. आर यू गेटिंग माय पॉइंट? देखो,
Yes, sir.
मैं तुम्हें बहुत ही सिंपल सी बात बताता हूं. एक्चुअली अभी तक आपने जो पढ़ाई की है, उस पढ़ाई में आपके टीचर ने आपको कंफ्यूज करके रखा हुआ है. आर यू गेटिंग माय पॉइंट? इसी कारण आप ये क्वेश्चन पूछ रहे हो. जैसे क्या एक्स एक्सिस यही है, इसी को मैं अपना एक्स एक्सिस कहूं, और वाई
नहीं,
एक्सिस
सर.
इसी को कहूं क्या?
No, sir.
नो सर।
I can say this is my x-axis and this is my y-axis, isn't it?
Yes, sir.
Yes. I can say this is my I cap and this is my j cap. Even if you are defining this is 1 0 and this is 0 1, I can say this value is 1 by root 2, 1 by root 2, and this value is 1 by root 2, and sorry, this value is minus 1 by root 2 and 1 by root 2. I can say this is my x-axis and this is my y-axis. Are you getting my point?
Yes, sir.
So if anybody is saying, no, this is my only x-axis, this is y-axis, this is my z-axis, I can claim, no, maybe this is, you are correct, 100% correct. But for me, this is my x-axis, this is my y-axis, and this is my z-axis. And this thing will be come out if your eigenvalues are degenerate. But if your eigenvalues are non-degenerate, then everybody will have same x-axis, same y-axis, same z-axis, as we have done into the last problem. For example, for everyone, this phi 1 is same, isn't it?
Yes.
So,
So if degeneracy is coming in the result, in the thing, then obviously it will create a problem. So how you will resolve this particular thing? This is the most important thing. Okay? And when we will go for the problem, then you can see why this, how we will tackle the thing of degeneracy in this particular quantum mechanics. Okay? Chalo. So this is the final statement. And what is this statement? The statement is for degenerate eigenvalues, one can find infinite set of orthogonal eigenvector. Orthonormal कर लो, orthonormal eigenvectors. Okay, so you have to be very much careful. एक बार TIFR के एग्जाम में क्वेश्चन आया था इस तरह से, which one is the eigenstate? Lot of people are working only with the 1 0 0 1 1 0 0 1 and they are just saying, okay, this is the eigenstate. But teacher give the eigenstate from another set.
इसी सिचुएशन
Yes.
में क्या हुआ था?
हाँ?
सर इस कंडीशन में क्या हुआ था कि टीचर भी सही है और स्टूडेंट भी सही है?
नहीं भाई, आप ये क्यों ये मिथ पाल रहे हो कि हमेशा आइगन वेक्टर में 0 1 1 0 ही रखेंगे? ये तो गलत मिथ है ना?
यस सर.
Okay? Okay. So I am just giving you one homework, and this homework will very important, and you can just post me now. I am just giving one of my favorite eigen matrix basically, and I think you have done, if you have done the matrix course from Alok sir, you have also done it, है ना? आपने किया होगा ऐसा. So all element is 1 1 1 1 1 1. Okay? What do you have to do? You have to find 3 orthonormal set of eigen vectors. कितने सेट आपको कैलकुलेट करने हैं इसमें? 3 कैलकुलेट करने हैं. ऐसे ऐसे कितने कैलकुलेट करने हैं? 3 कैलकुलेट करने हैं, और किसी एक में सिर्फ 0 का यूज करोगे. ओके?
ओके सर.
बाकी में 0 का यूज नहीं करोगे. आर यू गेटिंग माय पॉइंट? अब पता चला कि सब में 0 1 0 1 0 1 करके काम करने लगे. नो, यू विल यूज ओनली वन सेट में 0 का यूज कर लो. ओके, इट्स ओके. एंड बाकी 2 में आप नॉन 0 का यूज करोगे. व्हाट विल बी आइगन वैल्यू? 0 0 3. ओके, वेरी गुड. सो आइगन वैल्यू इज 0 0 3. 3 के लिए कोई प्रॉब्लम होगा क्या? सबका सेम आंसर आएगा या फिर डिफरेंट आएगा?
सेम है
Same है.
सेम आएगा। और 0 0 के लिए
इनफाइनाइट
डिफरेंट
नंबर ऑफ
आएगा, इनफाइनाइट नंबर ऑफ सेट। लेकिन मैं आपसे 3 की ही बात कर रहा हूं, ठीक है। सो 0 के लिए इक्वेशन क्या बनेगा? सपोज यू हैव A B C, that will equal to what? 0 A B C. That means A plus B plus C is equal to 0, isn't it?
Yes, sir.
और जब आप इसे सॉल्व करोगे तो आपको A प्लस बी प्लस वैसा वेक्टर ढूंढना है जिसमें A प्लस बी प्लस सी की वैल्यू 0 हो और वो आपस में क्या हो? ऑर्थोगोनल हो। ठीक है, ऐसे ऐसे 3 सेट निकालने हैं। एक सेट तो मैं बता देता हूं, A की वैल्यू 0 पुट करो तो B इक्वल टू माइनस सी, वहां से हो जाएगा आपका। अब बाकी 2 आप कैसे करते हो वो आप करना, एंड प्लीज पोस्ट इट इन योर ग्रुप। मैं चाहूंगा आज की क्लास के बाद आप 10 मिनट दो और इसे पोस्ट करो। ओके, सो दिस इज ऑल अबाउट योर आइगन वैल्यूज एंड आइगन वेक्टर एंड आइगन स्टेट। द होल थिंग इज दैट हाउ यू आर गेटिंग द orthogonal set of eigenvectors. Okay, so in the next class, in the next topic, we are just going for the commutation relationship for the operators. Okay, so I will take a break and after then we will go for commutation relation. Everyone is comfortable right now?
Sir,
Hmm.
it could be possible that there can be more than two degeneracy in the same problem.
Yes, there can be possible. Do you want that problem? So take it. Okay.
Yes, sir.
So take it this one. Okay. So here one will be triply degenerate. Okay.
Yes, sir.
If you are going to solve the eigenvalues, you can easily solve it and you will get one will be triply degenerate. Then what you will do? Then you can choose one orthogonal vector, one normalized vector arbitrarily, and that normalized vector have to be orthogonal to third one, and that have to be orthogonal to fourth one, and fourth and second and third must be also orthogonal. So you have to solve more orthogonal condition, isn't it?
Yes, sir. That's right.
Okay, and then you can find the answer. Okay, basically the basic mantra is what? Number of equation must be number of variables, है ना? तो एक तो आपका नॉर्मलाइजेशन कंडीशन से आ जाएगा, बाकी सारे कंडीशन कहां से मिलेंगे? ऑर्थोगोनल कंडीशन से। ओके, यस, okay, so I will just take a break. I will just clean my board and then we will go for what? Our next very interesting topic for quantum mechanics, that is what? Commutation relationship. Okay.
Yes, sir.
So I will just join after 5 minutes. Okay.
Okay, sir.